Good morning. I think I actually have just a few baby pictures that we can share with you all this morning. So if you could pull those up and go to the next slide, I'd appreciate it. It is an honor for me to be here with you all this morning. I've participated at the von Braun Symposium for many years. And so it's a great opportunity for me to be able to come and talk to you a little bit about what I have invested all of my time in over the last several months since the inception of the Moon to Mars program, a congressionally mandated program that has been stood up to ensure that we are doing the right things to integrate all of these collective capabilities into an integrated mission called Artemis. We were very successful under Artemis 1. But the recognition was that was probably the simplest and the easiest mission that we've had an opportunity to pull off. And every subsequent mission in our Lunar program is going to get more and more complex. And so we are pulling together as an integrated program to make sure that we are focusing in on doing the right things to develop a sustainable program on the surface of the Moon. Have our eye towards Mars as we prepare to go on to other bodies off of this world, and do so in a way where we can send our crew out there and bring them home safely. And so here's a picture of our moon. And there are locations that are pointed out, and in the animation you can see the locations where we landed on Apollo. And then there will be locations where we're landing for Artemis on the lunar South Pole. We are doing things differently. Even though we are returning to the moon, even though we are reestablishing American preeminence with our friends and our international partners, we are going there in a sustainable way. We're going there to stay. It's so fitting that we are having this conference on the campus of University of Alabama, Huntsville, because part of our objective is to inspire the next generation. And so we will be doing that in spades, motivated by science, because we know that that is the reason why we are going to discover new things, to understand understand how to live in a sustainable way, to practice, so that we can go on to other planets and other bodies. Next slide, please. Such an inspiring picture. And as our crew goes to this new location, they'll be representing us all. The other thing that we have to think about is that we will not only be returning to the surface of the moon, but we'll be doing a few firsts. We'll still be taking with us American souls, but it will represent our first woman, our first person of color, taking us all along for the ride with us. If you'll move along to the next chart. Mission accomplished on Artemis 1, and as I stated, that's probably about as quote-unquote simple as it gets. And so in a very stepped approach, we will be building on the great work and the successes of Artemis 1. You've been introduced to our crew. And so Artemis 2 will add that capability and all the human systems to be able to sustain them as they go, as well as science and payloads that we bring along with us. And then as we move along to the right, Artemis 3 will be our first landing on the surface of the moon. And we continue to build capabilities with the gateway as well, and all of our surface assets are there to follow. And so as you listen to these program managers and they talk about their experiences and successes from Artemis 1, and as well as we look forward to Artemis 2 and beyond, this is what they all have in the backs of their minds, the way that we can work together to ensure that the next missions are just as successful as the last. Next slide, please. And so I promised you a baby picture. If you go ahead and click on the animation. Right. We're breaking records. We're inspiring the future. We are being motivated by science. We are partnering with industry, and we are taking along with us our international friends and neighbors. And so I invite you to bring your attention to our 6 program managers who have made it happen for Artemis 1 and will continue to carry our success forward for Artemis 2 and beyond. Thank you.
Thank you, Lakeisha. Thank you for your insight and your leadership at NASA headquarters and your new role as the Deputy Program Manager for Moon to Mars. So we're going to switch gears. We're going to go through and speak to our panel members. We have a couple of questions for each of them to give you a chance to hear from them, and we will save time at the end for audience questions. So please start getting those ready and thinking about what you want to hear from our panel members. So we'll start with Mr. Honeycutt. We got a couple questions for him to discuss. So by all accounts, Artemis 1, SLS flew right down the middle, as we've said. And so as perfect as it's looked, how has that success influenced your team and been a motivator?
Yep. All right. Thank you, Joseph. Hey, first let me say our team takes a lot of pride in how well our systems performed on Artemis 1. As you all know, it was a great achievement, and I think the success that we had for the Artemis 1 mission is a testament to the team's hard work. I think if you talk to our team, I think they'll tell you we're doing everything that we can do to not let complacency creep into what we do. When I talk to the team, I stress that one of the biggest successes, the biggest threats for Artemis 2 is the success we had on Artemis 1. And so we got to be vigilant and not let that complacency creep in to what we do. You know, the SLS launch vehicle is one that's got millions of pounds of highly combustible fuel on it. We did fly right down the middle, and our goal is for Artemis 2 to do exactly the same thing, be a carbon copy of that. I don't think we took too much of a victory lap. We took a little bit of one, but not very much. And the team's back working really hard to make sure Artemis 2 is ready to fly crew, and it performs just as well as Artemis 1 did. There's a quote some of you may have heard. I won't give credit to who said it, but it's not mine. If the pain of discipline is better than the pain of disappointment. And I can guarantee you that we're working as hard as we can to be disciplined and vigilant to make sure that we do our job in supporting the return to the moon. As Joseph mentioned earlier, you know, the team's off working the things that we need to do not only for Artemis 2 and make it successful, but we're working missions all the way out through Artemis 9 right now. Artemis 1 did confirm the robustness of the SLS rocket. It's a good design. We've done a good job at understanding our margins and where the performance that we have on the rocket, and we're committed to doing the same thing and staying disciplined and vigilant for Artemis 2.
Thanks, John. I think you covered a little bit on question 2, but can you expand a little bit on some of the key takeaways from Artemis 1, from the data you learned and how we're using it going forward?
Yeah, so as, you know, as we talked about it being right down the middle, but as right down the middle as it was, that really is what jumped out in the data reviews. But I think for many of us, and for those in the room that were involved in the space shuttle program, you know that we were learning right up to the end after 130-something flights. And so we've had opportunity to learn from Artemis 1. I would say that's just the nature of launch systems. SLS was built on a foundation for heritage launch systems. But again, you know, we don't have a way yet to test in a combined environments, do a full systems test, combined environments test here on Earth, right? And so that was, Artemis 1 was really the first combined environments test, and it gave us an opportunity to learn a number of things, even though the launch was right down the middle. And I would tell you there's a lot of learning to do. For Artemis 2, we had already planned in some upgrades to improve our manufacturability of the rocket. I think for those that followed the launch campaign for Artemis 1 and the run-up to the launch, you probably remember, and I think I got asked some questions last year at this panel relative, since we hadn't flown quite yet, we got questions relative to hydrogen leaks and that sort of thing. So we had some good learning opportunities there. And then for future flights, we're going to continue to use the data from Artemis 1 to bring on processing improvements and help us make the launch processing and the hardware even more robust.
Good, thank you, John. Let's shift gears and talk to Howard on Orion. So the first time in a generation, we sent a human-rated spacecraft on a deep space mission to take humans further than we have ever before. So talk a little bit about Orion's performance and what we learned on this first mission.
Yeah, thank you. Good morning, everybody. Really happy to be here. I think John mentioned a little bit last year we were here. We were about to launch in November, and we were hoping for a fantastic mission, which is what we got. And it was because of the rigor and all the hard work that the team put together to make the mission possible. And first, thanks for the great ride into space. We were able to accomplish a 25-and-a-half-day mission, and our subsystems performed as well as we expected or better. And that was fantastic across the board, not only hardware but software. And we had 161 objectives that we were trying to accomplish on the mission, and we either fully achieved or partially achieved all of them except for 2. And the 2 we didn't accomplish, one, we knew we had a DFI issue before the mission. We knew we weren't going to get the data that we're expecting for that particular flight test objective. The other was the retrieval of the parachutes. Unfortunately, they sank much faster than we had expected, so we weren't able to accomplish that objective. But everything else we were able to do. And some of the statistics that I think many of you might have heard, or some of you might have heard, you know, we were able to generate 22% more power than we had expected, and we didn't use as much thermal rejection capability, less than 25, or better than 20. We had 25% more margin, let me say it that way, in terms of our performance. So really great across the board. The other thing that doesn't get mentioned, and when we talk about human spacecraft and the performance that we expect, not only from the hardware but the software. A lot of our vehicles today, in fact, all our vehicles are very dependent on software. And on Orion, we have 1 million lines of code, and we did not have any issues with our flight software. We had minor understanding performance of the flight software that we had to go and certainly look at as we go forward, but nothing that stopped the mission or had issues supporting the subsystems. And I think that was fantastic in terms of if you are in that industry or if you work in that area. That's one of the challenges. You know, when you build a spacecraft, a lot of times the hardware gets potted and the software guys get to fix the hardware not problems, maybe features is a better word. So that's coming from a software guy. But so I think, you know, in the end, when you put all those pieces together, you have the hardware and software and the amount of work that takes to integrate those pieces, the amount of work that it takes to pull that together through ground testing and the robust ground testing we all had to do together, demonstrated through the mission, and that's why we had a flawless mission in terms of our performance, and I couldn't be happier for that. And from a lessons learned perspective, you know, we captured 261 lessons learned from the mission, both from ground processing with Sean and his team, and on orbit. We're going through those. I think they're very good in terms of how we go forward improving on Artemis 2. Not only our ground processing and the lessons we learned from that, but also minor tweaks that we're going to need to adjust in the software. We do have new capability going forward as well, but certainly really great information that we gathered from the mission itself, and the team has analyzed all the data. We put together a very good package of not only lessons learned, but captured all the technical data and reviewed analyzed all that data and reviewed with the team how we could do better going forward, and I think that has been invaluable. And we set a couple records on the mission. Flew the furthest on a human-rated spacecraft, 1.4 million miles was our journey in that 25 and a half days. And the furthest point that human spacecraft ever gone from Earth, 268,563 miles. So very proud of our accomplishment and the lessons we learned from Artemis 1. And like Lakeisha said, we've got a lot more missions going forward, more complex, and we want to make sure Orion is ready to go in a robust ride for the crew.
Yeah, thanks, Howard. Let's follow that thread a little bit. When you talk about kind of the first crew flight, we've got Artemis 2, and we know the crew has a name now with Reed Weissman, Victor Glover, Christina Cook, and Jeremy Hansen on board to fly the Artemis 2 mission. Can you talk a little bit about, from a vehicle mission standpoint, what's going to look different for Orion with the crew flight?
Yeah, so I mentioned a lot of subsystems that we're counting on for Artemis 2 that we already tested in Artemis 1 through this flight. On Artemis 2, we will have new capabilities. The first one that's, I think, very important to the crew members and certainly for all of us is breathing and eating and doing other business. So we're going to have subsystems that allow us to do that. That's going to be the thing that we're going to test a lot before we commit ourselves to the moon. So we have a 24-hour HEO orbit, high Earth orbit, that we're going to check out all the subsystems before we commit and do a TLI to the moon. So it's really important that all those functions are working. The other thing that the crew loves is flying the spacecraft. And so we'll get an opportunity to do a demonstration. We'll do a prox ops demonstration with John's ICPS. So we're looking forward to that. Crew is actually going to take the stick and get about as close as 10 meters. So we're looking forward to having that demonstration before we leave for the moon as well. And so they'll get a chance to understand the spacecraft handling capabilities and really check out not only how the spacecraft performs in terms of control system and a response, but the displays and the information they're going to get and the situational awareness from the cameras that allow them to understand visually what is happening as they move forward onto another target vehicle. So I think that's going to be really important. Of course, finally, there's a lot of subsystems that inform them of what is happening on the spacecraft. The displays will demonstrate or will show the information from those subsystems, and they're going to be able to not only understand how well the subsystem's performing, but also do some things that are needed potentially if they run into some issues with the subsystem. And of course, are going to get us a lot of feedback in terms of how they're going to be able to run their procedures and operate the spacecraft as a first-time crew for future information that we're going to need as we perform more complex missions. We want to make sure that the cockpit environment is robust and reliable and provides them the information that they need to operate the spacecraft. So looking forward to that, those three areas, Joseph.
Thank you. I think we're all super excited about Artemis 2. We know the crew's training to get ready for that mission. Is going to be a tremendous day for the agency and for our country. The launch crew. Absolutely. Great job. None of this is going to happen unless our ground systems are there to support the vehicle and the spacecraft and the crew to get ready. And we're happy to have Sean here to talk a little bit about what's going on with the ground system. So after Artemis 1, the successful flight, we look forward to Artemis 2. What kind of challenges are you guys addressing from what you learned on Artemis 1 to get ready for this next flight?
First of all, it's great to be here. I've seen a lot of faces that I haven't seen in a few years, so it's awesome to be part of this symposium. You know, for me and for many of the other thousands that have worked on Artemis, the launch of Artemis 1 was a defining moment in our careers. And I'll never forget watching the launch of Artemis 1 when Charlie Blackwell Thompson, our launch director, gave the go to come out of the T-minus 10-minute hold. And we counted down T-minus 10 minutes, 9 minutes, 8 minutes, got down to 3 minutes, and I looked at my colleague. I said, I think we're really going today. And we got down to T-minus 6 seconds, and the engines on the core stage lit up, and you could see the glow coming out from the bottom of the mobile launcher. And then we got to T0, and the mighty solid rocket boosters ignited, and SLS and Orion was on its way. And we successfully cleared the tower, which was something I was really anxious for. And that doesn't happen unless a lot of things work right. We monitor hundreds, maybe thousands of measurements leading up to T0. The fact that we didn't have any violations of our launch commit criteria is a testimonial to the people that worked on both the flight and ground systems. SLS, Orion, and the EGS systems performed beautifully together, and I couldn't be more proud than the team that made that happen. You know, overall, you know, we were very pleased with the way the ground systems worked throughout the entire processing flow. As you all know, this was the first time that we processed SLS and Orion with our new ground systems at KSC. And for the most part, I thought the first flow went very well. And, you know, as most of you know, we're responsible for taking components of the launch vehicle and the spacecraft, servicing it, checking it out, and assembling it in facilities like the Vehicle Assembly Building. And if you would have asked me 5 years ago what was going to hold up processing in the Vehicle Assembly Building, I would have said software. And I would have thought that we were going to, you know, have more challenges with the integration of the flight software and the ground software. And it's really a testimonial to the teams that spent the time at the avionics labs for Orion and SLS in making sure everything worked. This was a first flow, so we did learn some things along the way and during every processing op. We've compiled what I consider largely relatively straightforward lessons learned to go into our procedures that we'll use for Artemis 2. And those updates are underway as we speak. Now, during launch countdown, John mentioned that we did have a couple of challenges with hydrogen leaks. So we've already made some changes to the interfaces between the flight and ground. And on the ground side, we've welded some fittings that were previously just standard connections. And we've eliminated the seal. And so we'll have a welded interface as opposed to a seal. And we've also, as you recall, during our final launch countdown, we implemented what we called kinder or gentler hydrogen loading procedures. And, you know, and so those loading procedures will be used again for Artemis 2. Now, John's team, in collaboration with the EGS team, is working on a more robust flight-to-ground interface for hydrogen in the future that may be available for Artemis 3 or beyond that. Let's see, post-launch. So you all probably heard about some of the unexpected damage on the mobile launcher. Well, back in February, you know, we were assessing, you know, what happened to the mobile launcher. We had some issues with our elevators, and we had some blast shields that surround the flame hole that were warped a little bit more than we had planned. So we've taken the results of the Artemis 1. Remember, Artemis 1 was very much a test flight. We've done the analysis. We've done the math. We understand the environments better. And we're making some relatively minor modifications, thankfully, to the mobile launcher elevator shaft and reinforcing some equipment up and down the tower. But overall, that refurbishment effort has gone very well. Our Comet contractor, Jacobs, has done a great job getting us through that, and mobile launcher refurbishment is no longer a concern for me as we move towards Artemis 2. Recovery, so, you know, I'll tell you, it's really important to, you know, test like you fly, and we conducted several underway recovery tests in the Pacific in conjunction with the Department of Defense. You know, we use one of their well-decked ships to recover Orion. And so on splashdown day, Orion did a great job. Howard and his team did a great job getting Orion right where it was supposed to be. And the recovery operations commenced after that, and they went very, very well. One of our prime objectives was to make sure that we didn't produce any what I'll call ground-induced damage to Orion and getting it on board the ship, and we didn't do that. So mission accomplished there. Got the spacecraft on board, took it back to Naval Base San Diego, and then transported it back to Kennedy. And so that all went very, very well. So all in all, it was a very successful mission for EGS. We're taking the lessons learned and getting ready for Artemis 2.
Great. Kind of following that theme, with Artemis 2 and crew on board, launch and recovery. And a lot of people don't realize you guys manage the recovery piece, which is critically important. That's the end of mission, to get the crew back safely. Can you talk about how your team is preparing for those new challenges with crew on Artemis 2?
Yeah, well, first of all, let me start off by saying that the safety of the Artemis 2 crew is by far our highest priority. I think about the crew every day, Reed Weissman, Victor Glover, Christina Cook, and Jeremy Hansen. And we're very excited to be launching our first cruise back to the moon in 50 years. And, as far as changes and getting ready, the ground system's ready for Artemis 2. The most obvious one is installation of our emergency egress systems at the pad and on the mobile launcher. So those construction efforts, it's done. And we're entering a test phase. It's going to be emergency egress baskets similar to what we had for Apollo and Shuttle. And that testing will begin, literally within a couple of weeks. And so if we have a reason for the flight crew to have to egress the spacecraft in a hurry, they'll get in the egress baskets, they'll ride down the slide wires to a terminus within inside the pad perimeter, and then they'll take armored personnel vehicles and drive away from the pad. Recovery procedures have been updated. We just went through a full rehearsal, another underway recovery test in July. We actually plan on one in February that will have the actual flight crew for Artemis 2, and we'll go through the entire recovery procedures that we'll use on the actual mission.
Outstanding. Thank you. So moving ahead in Artemis missions, what comes next? We're preparing for cislunar operations with Gateway, and so we're glad to have John here. John, we talk about the Artemis program as a program where we go together, right, with our international academic and industry partners. Can you discuss the international partnerships and component and collaborations that are involved in preparing for Gateway?
Yeah, absolutely, Joseph. Thank you. And I also am honored to be here at the symposium. I also want to mention, kind of on behalf of Lisa and then Laura Kearney and the EVA and Surface Mobility Program, as well as the new entities coming on, right? Looking at the programs represented to my right and what they did with Artemis 1, very inspiring for us, but also the lessons that we bring forward that have been talked about here, the rigor, the diligence, the discipline and focus that the teams brought to the execution are all lessons that we apply in our programs as well as we look to build out the new capabilities as part of Artemis. So you mentioned international partners and industry. I'll start a little bit with industry simply because Gateway works closely with many commercial partners, just like all the rest of the programs, as we're building out the Gateway initial capability in particular. Initial capability will be a co-manifested power propulsion element that's being led out of Glenn Research Center and developed by Maxar Technologies, and a habitation and logistics outpost led out of JSC and being built by Northrop Grumman. But even with that, they have a number of supporting domestic vendors, the Redwires, Collins, Paragon, to name just a few. There are many, many others that support. But there are also international vendors that support those activities on the initial capability. You've got Thales Alenia in Italy, TT Tech in Vienna, Airbus Crisa out in Madrid, several of those supporting even the initial launch that we're going to have. But the PPE and the Halo, those elements will be integrated together at KSC, launched together on a SpaceX Falcon Heavy here in a few years to establish the initial capability for Gateway. SpaceX is also providing our logistics capability for Gateway as we go into the future. But Gateway at its core is an international endeavor. Story of Gateway really is one of profound collaboration with international partners under NASA leadership, right, where we're working daily with ESA, we're working daily with JAXA and with CSA to bring all of the elements of Gateway together. As I mentioned, the first launch has international vendors, but we also have international partner contributions on that first launch. We've got a lunar comm system from ESA that's being provided that'll be part of HALO. We have batteries being provided from Japan, robotic interfaces from Canada, and we have international science payloads as well launching on that first mission. From there, as we build out Gateway, ESA will provide the international habitat. So that will be, it'll include ECLS from JAXA, first of all, so integrated habitation module, and that's planned to launch with Orion on Artemis 4. ESA will also provide a refueler module that is planned currently to launch on Artemis 5. That refueler will allow us to refuel Gateway, maintain our capability in cislunar space out beyond the 15 years that we're currently planning. They're also providing within that refueler additional volume capability and windows. So that is going to be the crew's source to look out from Gateway as well. And then Canada is providing Canadarm3. That'll be out on the exterior of Gateway. It'll be used for maneuvering payloads on the external surface of Gateway, as well as for maintenance activities within Gateway. And then JAXA is providing a logistics capability in the future as well to augment what we're already working on with SpaceX. So our international foundation is actually very solid and strong. And as you said, we are going, and we're going with our international and commercial partners.
Outstanding. Thank you. So as we talk about the Moon to Mars objectives, Gateway plays a key role with that. Science is one of our whys behind the objectives that we have. So talk a little bit about how Gateway is going to enable cislunar science and utilization and the plans that are going for that.
Absolutely. Thank you, Joseph. And I really appreciate the why question. We're absolutely returning to the lunar surface, and there is a lot of scientific investigation to do on the surface. There's a lot of operational knowledge to be gained on the surface. But that's not the end of the story. There's, as we look to establish really a sustained presence in cislunar space with access to the entirety of the lunar surface, when we look to understand long-duration operations in deep space with access to and from different planetary surfaces, to create an aggregation point for future capabilities, whether to test out those capabilities or use that as a springboard for future exploration, to have a home away from home for the crew, to build a blueprint for that future exploration of Mars and beyond, and yes, to conduct additional science in the cislunar environment continuously. And we're going to need to establish Gateway really as the cornerstone for that continuous presence in deep space. So Gateway will operate in a near rectilinear halo orbit. It's largely outside of the Earth's magnetosphere, where we can continually study heliophysics, understanding space weather, radiation environments over time. That continuous capability for evaluation of those types of objectives, radiation, are extremely important to our knowledge as we move forward deeper into space. Gateway will be an autonomous vehicle as well. When you talk about flight software, we're building an autonomous capability within Gateway that allows for that continuous operation of science. We'll also have the opportunity to evaluate the effects on crew while they're present. So human research, biological research, other astrophysics research, all of those things are enabled by having the Gateway platform in space. And referring back to the international partner conversation that I mentioned earlier, right? Gateway also provides access to cislunar space for our partners to conduct science as well, and then data is shared by all as a result of that collaboration.
Continuing to expand our knowledge and discovery we'll be able to accomplish on Gateway is very exciting. So last but not least, to get us back to the lunar surface, Lisa Watson-Morgan, our program manager for the Human Landing System. Coming online for Artemis 3. Your team is working hard to get there with our industry partners. How are you integrating your program now with the rest of these programs that we have within the Artemis campaign?
Yeah, thanks, Joseph. And, I too am excited to be here today, but also to be part of Moon to Mars, which I think was a very excellent move from Congress and the administration, because I think it's really important to know, HLS, Human Landing System gets a lot of attention, both good and bad. But frankly, we can't go to the moon without everybody else that you see here, as well as Laura Kearney from Suits. And likewise, they can't go to the moon without us. And so we are this symbiotic, inextricably linked set of elements and an important suite of missions that we have moving forward. So we won't go without anybody else that you see up here. We just can't. That's the way the architecture is set up. So for us, integrating across has been very exciting, but it's also been a little bit challenging because, as you can see, as John alluded to the right, there are much more mature systems that have flown, that have proven capability. And then when you look at Gateway and Human Landing System and Suits, with their partners, these are in development. And so we have these asymmetric developments, and we're all working towards a single integration for the various missions. But I'll tell you, our systems engineering teams work incredibly well together. Our cross-program work is definitely much more in sync. We have quarterly reviews with Moon to Mars where we all get together and talk through, here's our open work, here's our expected completion date. It sounds very boring, but it's not. It's incredibly exciting, let me tell you. But it's really important. A lot of people say, oh, well, those are just documents. No, they're not just documents and requirements. These systems have to dock. They have to match up. The software has to be able to communicate. We have to be able to find their relative nav if we're going to go up and do this prox op and docking. So there's so much that is really exciting, and I would say we're marrying up very well, I think, with the traditional, more traditionally procured type systems. And there's certainly a lot of challenging items along the way, but also with those challenges are opportunities to do things differently, to learn from them, for them to learn from us too.
So all of our panelists have talked about partnerships in some way. So Lisa, kind of expand a little bit on how partnerships are really helping our purpose and how it's really affected how you've set up your program.
Yeah, thanks, Joseph. So for HLS and for the Human Landing System, I think most know, but if you don't know, so we are partnered with SpaceX for Artemis 3 and 4. And we are partnered with Blue Origin-led team, partnered with Lockheed Martin and others for Artemis 5. And it's a very unique approach. It's a firm fixed price contract. We have around, in 20 to 30, we have a few handfuls of requirements that we have not changed. They have been quite stable. Now, as I mentioned earlier, we talked through some of the cross-program work. As these very complex, unique systems work together, we find new things. We do additional analysis, more than first and second order, and we realize that we have to make updates to these interface agreements. So working in this fixed price arena, it permits us at the agency to do more with funding, but it also creates these giant challenges for us in that how do we hold requirements firm, and how do we, hold the providers accountable when, they're marching down and meeting their performance-based milestones. And we're also, I would say, bringing along the agency in addition to a lot of our independent analysts, like the standing review boards, the independent review teams, the aerospace safety advisory panels, because the past experience of NASA has been incredibly successful. And we were charged on HLS to try a different model in this partnership with industry, to commercialize the moon, to try to lean forward as much as we can, to use as many of their standards as long as they meet the intent of what we're doing. So what that means is that we have to get very deep down into how they are doing things. How will they execute? What standard will they use? To what, double ball this. And we do all that work up front. We do it up front so there are no questions or concerns or confusion as to how these systems should be built in order later on for our team to come in and be able to human rate the system. So it's super challenging. It is super exciting, and I all the time get asked, how do you sleep at night? And I'm just going to tell you, I sleep very well at night because I take it one day at a time.
Thank you, Lisa. Good advice. So that, I think it's time to move to audience questions. I've asked enough. I want to invite Lakeisha back up because she doesn't get off the hook for being able to answer some questions too. So please come back and join us. And we have some microphones floating around as you guys warm up. We see some hands come up. I'll give you your trivia for the day in case you go play trivia tomorrow. 62 years ago this week, NASA did the first Saturn Apollo 1 stage test to prepare for the Apollo missions. So I thought it was pretty timely with us discussing Artemis 1 as our first flight test for this campaign to return humans to the moon to connect those milestones in history. So there's your trivia. Maybe you'll win some wings later. All right, the lights are bright. We got any questions out there? Let's see.
Thank you so much. And thank you, everyone, for your introductions and your presentations. I really appreciated the insight and the information that you shared with all of us. My question for all of you, anyone interested in answering, is with the complexity of this program and the interactions, and we talked about working together through all of these different projects, but over just the length of the years that this Artemis has been coming about and trying to actually be finally achieved now, what has the process of configuration management been? Getting a little bit more nitty gritty. How have there been any advancements in communicating around the country, if not the world, over the years?
Kick it off.
Who wants to take that?
You turn your mic on.
Yeah, who knew we would be coming to Braun and talking about configuration management, huh?
That's a great question.
Yeah,
That's
that is a great question. So one of the reasons why we have been looking to try to get Moon to Mars in place is to make sure that we actually have an integrated approach to our problem solving, and that includes making sure that we're all level set with respect to requirements, level set with respect to risk, which is super important to us. Obviously, Artemis 1 was very successful, but as we bring on additional partners, as we bring on additional international partners, we all need to be working together to ensure that we're speaking the same language, making sure that either we're all in English or all in metric, things of that nature, right? And so I think where the rubber meets the road is at our interfaces. Right, and so we will be working across the programs, across the elements, to ensure that we have as high a level as possible so that these elements can implement their own approaches, but make sure that we have good interface definition so that we're all on the same page and making sure that we'll be able to marry up as needed. Anything else from the other programs?
I might just add, what Lisa said from the SCNI teams working really closely together across Moon to Mars. I know John was ready to jump in too. I know it really was important for Artemis 1 to have that integrated perspective. And we see it already in the buildup of the new elements. We actually just had an NRHO checkpoint activity, an integration activity with all of the programs that are going to meet out in NRHO, trying to address all of the different aspects, the configurations that we'll have to deal with out in that environment. And the aspects of configuration management, data management, understanding that systems and engineering and integration challenge are all part of what that activity actually brought to the forefront as well. So it's another example. It happened in order to achieve Artemis 1. It's going on for Artemis 2, and we're already implementing capabilities out for the future as well to address all of the different aspects that you would typically see under systems engineering across Moon to Mars.
Thank you. Good question. Others?
Thank you so much for this panel. It's very enlightening. So for the Moon to Mars offsite last week with industry, are there any key takeaways you'd like to share with us today? Thank you.
So what she is referring to is another one of the objectives that we have tried to implement within Moon to Mars. We are taking a cue from Apollo and pulling together everybody who is contributing to the success of Artemis. And that not only includes the government and these program managers that you see here and their teams, but industry as well. And we all got together with both our NASA as well as our industry leadership out at Uvar-Hazy out in Washington. And we had some very open, very honest, very frank conversations about how we were going to work together and integrate together to pull this off. That included a discussion on a shared sense of accountability. And that included a commitment from both our program government team as well as our commercial partners to committing to working together and making sure that what they did had a recognition of the impact of their moves, their messaging, and how that impacted the other elements and the partners that they were working along with. What was amazing about that conversation was how successful it was. We got buy-in from each of those leaders that was represented at the table, and they were sitting right next to their counterparts, their program managers here with the government. We expect to continue those conversations, and we expect for the public to begin to see the fruits and the results of that commitment. So thanks for that question.
So I'm going to address this to Sean and Howard. As a child of Apollo, young child of Apollo, one of my most vivid memories was the splashdown. And watching Orion just took me back to those memories of watching that as it come in. But the recovery, I would say, was very deliberate, if I can use that word. Are there, and I'm, I know this is a surprise to people in this room. I'm not a very patient person. And when I fly, I really want off the airplane quickly. Can you describe the process of recovery for the crew on Artemis 2, if there's any changes, and how we'll see that happen?
Well, the most obvious change is that we're going to be helping the crew get egressed out of the vehicle, and but the basic procedures are the same. You know, we have to make sure that the spacecraft is safe to approach. So we'll send, you know, divers into the water, and they'll have measurement devices to make sure there's none of the hazardous commodities, still residual hazardous commodities around the spacecraft. Once that's cleared, then you know, we'll send some medical crews into the spacecraft, and they'll do a health check on the crew, and then we'll begin our egress procedures. we do intend to get the crew out as quickly as possible because they'll have been, in orbit for, 10 days or so on Artemis 2. And then we'll get them back on the ship, either via helicopter or rigid hull inflatable boat, depending on the conditions at the time. And then they'll be on their way back to JSC at that point. The timelines itself, we do have goals. I can't remember exactly the time that we want to get the crew out, but it's certainly less than 2 hours, probably, well less than 2 hours. And we've tested that once already in July, where we went through an entire recovery test, and we'll do it again with the crew in February.
On it, Chris, I don't have much to add. I think it's really important. We talked a lot about getting the crew out as quickly as we can. Of course, there's a balancing act. We do want to reuse some of the components inside the crew cabin. So this is the balancing act of going forward in terms of, making sure we're protecting not only the crew safety and getting them out, but also Sean's team's looking at ways to make sure we minimize any water intrusion and things like that to limit the exposure of the critical avionics that we're going to need in the future. And obviously, if the crew needs to get out, they'll be first priority, as always. But that's the balancing act we're going across all the recovery. And I think the EGS team is really helping out to find creative ideas to ensure that not only we get the crew out as quickly as we can, but ensuring that, the spacecraft's in good shape, so when we get it back, we can reuse it in a lot of different ways.
I think we have made time for one more question.
So we'll be hearing about commercialization opportunities a few other panels, but you're really in the thick of it right now, especially on the gateway side. I'm interested in what sorts of commercialization opportunities you see that are coming out of the Artemis program.
I give you one, is I think folks have heard that we're exploring this exploration operations contract for SLS, which would essentially turn into the government purchasing a service from this group that's now called the Deep Space Transport, right? It's interesting when you talk about commercial, right? But because I view my prime contractors on SLS as commercial entities. But this would be more of an arrangement to where the government was more of an acquisition contract management insight role versus our insight and oversight role we have today. That sounds appealing to me and a lot of folks, but the devil's in the details. And so we've got a team that's led by my deputy, Chris Cianciola, that works diligently with the rest of the leadership team on SLS to execute the acquisition planning for EPOC. And so we're just getting started on that, but point well taken, right? And so the goal here really is to free up SLS as a commercial vehicle that a commercial entity could market and use for things other than just SLS.
Yeah, and when you take the kind of look from the gateway perspective, John mentioned commercialization has many different types of definitions, right, depending on the perspective that you bring. And the one that John mentioned, right, the contracting with commercial entities, I talked a little bit about that earlier, that we have that. But you look at ISS and how its role in commercialization evolved over time. I don't necessarily want to speculate on exactly where Gateway will end up, but the capabilities being built into Gateway, first to support what we're doing with Artemis, right? That's the prime activities there. But using building to interoperability standards that exist that allow our international partners and others to participate provides an opportunity, at least for the future, to have the discussion about how commercialization evolves over time. But our focus at this point in time really is making sure we're building out the capabilities that we need to execute the missions that we have now to get back to the surface and do that continuous investigation, science investigation in cislunar space.
All right, well, we are drawing to a close. Honored to share the stage with these agency leaders and their work to lead us to the next set of missions for Artemis and these goals that we have. Thank you for the engagement from the audience, and look forward to a great symposium for the next couple of days. Thank you.
Yes, thank you very much to our panel. Great way to kick it off. Very happy to have you all here. If we haven't met, my name is Jim Way. I'm Executive Director of the American Astronautical Society. Very happy to have you all here today. As we transition into our next session, I'm going to invite our next panel to come on up and take your seats. We'll get your name placards out and take care of some water and things like that. As you saw up there was a slide before on Q&A. So you saw, don't hesitate to ask any questions out there. We've got microphone runners. And for you folks online, we will be monitoring the Zoom webinar and pulling any questions that you pose from that to ask them here live. Also, this is a great event, and I hope you all are having a great time. If so, please don't hesitate to share your experience on our social media channels. On your own channels, you can copy us in. Our hashtag is up there at the top. So please don't hesitate to post some good things about it. And if you don't have anything good to say, you can come talk to me, and I'll listen. So as we get going, I also do want to make a pitch. We have a student poster contest taking place tomorrow night, for which we need judges. It's a really easy process. We actually have the judging thing on a phone app, and I'll buy you a drink at the reception if you become a judge for us. We have 28 student posters that need reviewing, so we need about 24 judges because you judge 2 or 3 posters each, and it's a great way to learn more about some really amazing stuff that these students are doing.